Today's tinkering is accompanied by Flirting with Goth, dark ale from Bookstore Brewing in Winnipeg. They describe it as roasty, calm, hints of spice and malt sweetness, and a light bitter finish with light coffee on her lips, but not actually coffee, I think. Okay. Yeah, no coffee, just normal beer stuff. So today I'm going to be taking a look at this power supply that a buddy of mine gave me. It's not working properly, he says, as you may be able to surmise from the tag he put on it. He doesn't expect me to repair it. I'm going to give it a shot anyway if it is repairable. Otherwise, I will just do a teardown. We'll see how this video progresses. So this is a somewhat unbranded 48 volt DC power supply. It claims to be able to put out 20.8 amps at 48 volts. But of course, based on his assessment here, it doesn't seem like that is what it's doing. So let me just connect up power to it and we will give it a test and see what it's doing. Okay, so plugging in power, we get an LED there. I'm not sure whether you could hear it over the other fans, but there's a fan in here that's just started up. So what do we have for voltage? We have 48.2 exactly. Okay, let's see if we can tweak this little adjustment pot here. It happens to go way up. Okay, so we can go up to 50. What's the max? Let's just crank it right to the top. Seems like 51.8 or 9 is about the max. Okay, let's come down. 48. Let's see if we can get exactly to 48 with no load on it. I mean, theoretically, if it is a well-regulated power supply, it should hold no matter what the load is within the range, right? In theory, anyway. So if we add some load onto it here, these two... Huh. That's weird. Yeah, there's no load there. Huh. Okay. I don't understand. That should have loaded it down pretty effectively. That's two 8-ohm resistors in parallel, 4 ohms across 48 volts. 48 volts over 4 ohms should be like 12 amps. That should have done something. Well, that's disappointing. Looks like it does have some kind of an internal discharge for its capacitors, though. I guess that's something? But why wasn't that loading it down at all? I guess there is only one way to find out. Let me just get these disconnected here. Actually, I don't think I need to disconnect the power cord. You can see that it's there. I'm just going to drop it on the floor so it's out of the way. And we'll take it apart. It appears to have only a couple of screws holding the main cover on. There's this one on the back, and this one down here by the terminal blocks. And other than that, it looks like it's just clipped on up here somehow. Yeah, there we go. No skid marks on the inside of there. That is just dust from the fan. Okay, so what do we have in here other than dust? And plenty of it. So lots of stuff going on in here. First thing I see is a 110 220 volt input switch, which is kind of nice. Although when it showed that it was universal voltage on the outside, I thought that it might do it automatically. What is that? That is a big bridge rectifier right beside there with a heatsink on it. Transformer, 1000 watt, 48 volt, it says. A couple of good sized capacitors. What are those? Those are 1000 microfarad at 250 volts. So those will be on the DC just after the rectifier. I guess we should follow the path of the power coming in, but I'm going to wait until I pop the board out to do that because I suspect it'll be easier. Anyway, what other notable things do I see here? We've got an 8-pin chip there, got a 4-pin chip down there, which I'm going to assume is an opto isolator between the high voltage and low voltage side. There's the fan power, and a couple of devices here sandwiched to a heatsink which is attached to the outside case. And I'm assuming that too is on the high voltage side, or the mains side. That transformer should probably be the break between the high and low voltage side. That inductor, I'm going to guess, is just series filtering, and those will be output capacitors. And then underneath this heatsink here, which is not touching the case, there are 4 fairly beefy devices in there, which are probably going to be diodes. Oh yeah, that's exactly what they are. Those are diodes. So those will be on the secondary side of this, on the low voltage side. And presumably 4 of them in parallel to create that, what did it say, 20.8 amp output, and then some filtering capacitors in the DC outputs. Not quite sure where that variable resistor goes to, but I'm going to assume that it is creating a voltage divider against probably either a voltage reference chip or a Zener or something to supply feedback back to the that's going to be a switching chip then, I guess, and back through the opto-isolator. At least that's my assumption based on what I'm seeing here so far. Let me just get this a little bit further apart and see if there's anything obvious going on underneath that I'm missing out on. There's a couple of screws on the other side, and then one hiding underneath there, which is the one that goes through that heat sink. This one over here to hold those guys clamped down. I'm pretty sure that has to come off in order to get the board out. Also, I will unplug the fan. Let's give that a little pry, because there's probably some heatsink goop behind it. Oh, so it appears that little block of aluminum is actually screwed to the outside of the case, and then there's that little retainer holding those guys in. All right. Plastic sheet, that's good to see. Oh, look, it's a symptom. What are you? You look like a little capacitor who has had the end blown out of you. Okay. Did it short to that little piece of bodge wire there? It's charred, but I don't think it's broken. I'll probably drop some heat shrink over that anyway if I repair this. But yeah, that is definitely a failure. The question, of course, is why did it fail? And what is it attached to? It appears to be across a couple of windings on this transformer here. And from what I can tell, there is the windings from some of the windings from the transformer, and there is some of the other ones. That is the secondary side. So it looks like all the windings are just in parallel. There's I can count 5 different windings on this side, but they, like I said, they appear to be all in parallel down here. And just for separation, we have those holes, and there is the primary side of the transformer. It looks like we got a capacitor across those 2 windings, so that will be the primary winding. This will be likely a feedback winding, which goes over to this corner of the circuit over here. These 2 heavy primary tracks are coming from, there's a jumper wire there and a jumper wire there. So they are coming from these devices here, which are, what are you? This one is a 47N, a 6 or an 8, I think that's a 60C3. And this one is 47N60C3. Oh, all right, they're the same thing, just different markings, presumably from different batches or something. It is a power MOSFET capable of dealing with up to 650 volts, which is way above what it'll be seeing here, but more importantly for our application, it can pull 47 amps through it. And judging by this, one of them is driving this side of the primary, and the other one is driving this side of the primary, and there's a little capacitor across the primary just for good measure to get rid of the high frequency ringing and stuff. Okie dokie. Let's look closer at this power supply chip just to see what it is. I mean, we've got a pretty good idea what it is, but might as well look at the specs of it. LD7575. This is a PWM controller. All right. Here is one of their suggested applications in a power supply mode. AC input, filtering, bridge rectifier, big bulk capacitor, sampling from the high voltage side here. We go through a transformer, MOSFET drive coming from the output, driving the other side of the transformer, a current sense, a compensation coming from the photocoupler. This is very likely what we've got going on our board here. A little inductor there, and I think we saw a little one of those on the board too. Sure, that is very likely what we've got, almost component for component. So let's just follow this circuit through here a little bit. There is the two AC inputs. One side goes to the fuse, the other side goes to these two devices here, which are NTC thermistors, so just calming down the input inrush of current, I'm guessing. And then after that, we have this class X2 capacitor. We have a common mode choke, another class X2 capacitor, a little tiny capacitor, which goes back to ground. That's likely a class Y safety capacitor. And then we have the 110-220 switch. We have the big 1000 microfarad capacitors. Then we go over through a couple of resistors to the MOSFETs. And where's the chip? There's the chip there. That's the inductor that we were talking about. Let's see now, pin 2 of the chip, which is the, what does it call it, compensation. Yeah, that comes over here from the opto isolator. So that is all kind of what we expected. And back to this blown up capacitor here. I am going to guess that it is just for stabilization. I don't know why it would have exploded though. Let's see if we can read that. Looks like 222, which is a 2.2 nanofarad. And I think I've got a whole bunch of them here. There's one. That is a big pad. It's going to take some time to melt the solder off it. Plus the big wires to the transformer on the other side, but we'll get that guy out and get him replaced. And like I said, I don't know what would have caused that to explode like that. Whether it was just in too close a proximity, whether it cracked and fatigued from thermal over time, I don't know. But we will get this replacement soldered in there. There's only two contacts here electrically. There's the one that I'm on, which is electrically the same as all this. And there's that one here, which is electrically the same as all this stuff. And I think I probably ought to put a little bit of heat shrink on that guy just to keep him from shorting onto there. I don't know if that's what happened in the first place, but I think that would be a prudent thing to do here. And just for good measure, I think I'll put a little bit of Kapton tape underneath there. It can take the heat, and it is electrically insulating. So I think that would be a reasonable thing to do. I don't think it's going to hurt anything anyway. It's certainly not going to be affected by any heat that's going on here. There, I think I feel a little bit better about that. And then this bit of wire here, I said I was going to put some heat shrink onto that too, didn't I? Maybe I should just replace it though. That might be the safer thing to do. As I said, I don't think it's damaged, but I don't want to take the risk just in case. So that wire is taking the positive output voltage, running it around the long way and bringing it down to these components down here. There's a diode down there, a handful of resistors, a 3-pin device which may or may not be a transistor capacitor, and the voltage adjustment pot. Anyway, I'm wondering if by replacing that capacitor we have stabilized this thing, or at least brought it back to life. Let's knock some of this dust out of here, put it back together, at least enough to test it, and see what happens. Is it brave of me to put the case on before I test it? Or is it just a good idea in case it explodes in my face? I don't know. Comments down below. Am I being chicken or am I being prudent here? I think I'll leave that back screw out just for laziness. Okay, back together. Let's see what happens. Oh. Well, that wasn't supposed to happen. I don't know whether you saw it or not just before the lights went out, but there was a bit of a flash from in here. So I don't think this is going to be the repair video that I thought it was going to be, unfortunately. Presumably there was something else caused that that capacitor to fail, or when it failed it took something else out. So let's just see what's gone smoky on us in here. I'm hoping whatever happened. Well, nothing obviously exploded under there. Nothing's obviously exploded over here. That fuse didn't blow. Okay. These thermistors. Actually, let's go back to just resistance. These thermistors are showing like 1 ohm. It's been long enough that they will have cooled down. I'm not seeing anything obviously smoked under here. I do not know why it drew all that current and popped my circuit breaker. But again, not enough current to blow that. Weird. I'm going to spend a bit of time poking around in here and test a few components. Notice that this capacitor here, which is the one in, or one of the ones on the primary side, and it's the one that's in the 110 volt position. When you switch that, it basically introduces this capacitor into the mix. So I'm going to pull him out and just see. Let's see what this capacitor has to say for itself. Yeah, that's pretty close. Okay, just for fun, let's test this blown up one. 70 picofarad. Okay. That's a long way from what it's supposed to be. Which is no surprise since it's got the end blown off it, but that may have caused other damage when it exploded. Just not damage that is visibly obvious in this circuit. I'm not sure how much time I want to burn on this thing. His buddy that gave it to me said that I could do a teardown on it. He didn't care if I repaired it or not because he has already bought a replacement. Might as well check that bridge rectifier and see if it's still happy. Yeah, it looks like it is. Diode drops in all the right places. And none where they shouldn't be. Okay. Check that there's no shorts across these input capacitors. That looks like a capacitor charging. There's the capacitor on the other side of the inductor. Yeah, that's good. Let's check the MOSFETs. Let's see if they are shorted out. Okay, that one looks good. And the other one, no, that one's good too. Similar characteristics, okay. So I think that's as far as I want to go with this thing. I'll probably salvage a few components from it. My buddy that passed this on to me is probably going to watch. He may or may not comment down below. He may or may not wish to identify himself, and that's perfectly fine. But I know that he's already replaced this thing, and I know that he didn't really expect to get it back. So there is where it sits. The symptoms are different than when he gave it to me. And I don't think it's improved, but I don't know where to go any further. I don't have a lot of experience successfully repairing switch mode power supplies. I have a basic understanding of them, and I suppose I could fire the parts cannon at it, but realistically, it's not worth my time at the moment. I've learned what I wanted to learn from it, I think. I still don't quite understand why that guy exploded or what caused it, unless, again, it just fatigued and blew it out. That is on the secondary side of that, so the DC side, which I suppose there could be something shorted on there, maybe even in the transformer itself, that caused enough of an inrush to blow my circuit breaker. But as you saw, it was working before I tried to repair it, so yeah, there it sits. Anyways, thanks for watching. I appreciate that. As always, questions and comments down below as you see fit. I will talk to you later.